Vipin, can we start? Yeah, so go ahead. Let's start now. I hope all the people came. We can go ahead. Just give me 1 minute. Yeah, I'm starting. Yeah. Yeah, fine. So let's start now. Let's start now. Algorithms. So this is the one. Yeah. Before going to start, yeah, please say everyone good evening one time. We can start now. Everything is ready. We can start now. Everything is ready. Please say good evening one time, everyone. Everyone say good evening one time. I hope everything, audio, video, everything is okay. Audio, video, everything is okay. Say one time good evening, everyone. Make it fast. Everyone say good evening one time. Right. So I'm starting now. This is the first class of algorithm subject. Right. This is the first class. So I written the algorithm also. Right. So the book which you can refer at any point of time if you have doubt, you can refer this book, reference book. reference book. Reference book, Introduction to Algorithm by Coreman. Introduction to Algorithms by Coreman. Recent edition you can go. I think maybe 4th edition or 5th edition, I don't know. Recent edition you can go. So this is the book which you can refer, right, to this subject purpose at any point of time if you have doubt, right? So you can refer this book, Introduction to Algorithm by Coreman. Recent edition you can. Recent edition you can go ahead. Right. Hi. Yeah. Good evening. Good evening, everyone. Good evening, everyone. So I hope everything is fine. So this is the book which you can refer. Yeah. Come to the next one. Come to the next one. Read on. Syllabus. To the subject syllabus. Algorithm subject syllabus is going to be first one. Analyzing algorithm means finding time complexity. First one is analyzing algorithm. Analyzing algorithms. That is the first chapter. Analyzing algorithm, that is the first chapter where you will find out time complexity, space complexity. That is the first chapter. You will find out time complexity and space complexity. That is the first chapter. So second chapter is going to be recursion, recurrence relation. Recursion and recurrence relations. That is the second chapter. Recursion and recurrence relations. That is the second chapter. Third one is recurrence relation solving. That will be the next chapter. Fourth chapter, asymptotic notation. Where we will find out, where we will discuss about big O, omega, and theta. So fourth chapter is asymptotic notation. Right? First, analyzing algorithms, time complexity, space complexity finding. Next one is recursion, recurrence relation. Next one, recurrence relation solving. Right? Fourth one, asymptotic notation. Right? Next one, fifth one, divide and conquer. Where you will see in the divide and conquer, you will see finding maximum minimum, finding maximum and minimum. Divide and conquer, in that first one is finding maximum minimum. Second one, power of an element. Third one, binary search. Please write the topics first. So fourth one, merge sort. Fifth one, quick sort. Sixth one, counting number of inversions. So 6th one over 7th one. Maximum subarray finding. Maximum subarray. Maximum continuous subarray sum. Continuous subarray sum. So eighth one, Strassen, I think selection procedure. Selection procedure. Ninth one, Strassen's matrix multiplication. Strassen's matrix multiplication. So this is the divide and conquer story. This is the divide and conquer story. Please write all of them. This is the syllabus. First, analyzing algorithm. Second one is recursion, recurrence relation. Third one is recurrence relation solving. Fourth one is asymptotic notation. Fifth one is divide and conquer. In that first one, finding maximum minimum, power of an element, binary search, merge sort, quick sort, counting number of inversions, maximum continuous subarray sum, selection procedure, Strassen's matrix multiplication. So these are the topics in the divide and conquer chapter. So next one, sixth one, greedy technique. Greedy technique. In the greedy technique, first one. In the greedy technique, first one, knapsack problem. Knapsack problem. First problem is a knapsack problem. Second one, job sequencing with deadline. Job sequencing with deadline. With deadlines. Third one, Huffman coding. Huffman coding, third one. Fourth one, optimal merge pattern. Optimal merge pattern. So fifth one, minimum cost spanning tree. Minimum cost spanning tree. Sixth one, right? Fifth one is minimum cost spanning tree. Sixth one, shortest path, single source shortest path. This is the sixth one, greedy technique, knapsack problem, job sequencing with the deadline, Huffman coding, optimal merge pattern, minimum cost spanning tree, single source shortest path. These are the 6 techniques. 4 plus 2, yeah, 6 techniques. Go to the next one, seventh one, dynamic programming. Dynamic programming. In that first one, Fibonacci series. Second one, longest common subsequence. Longest common subsequence, which is also called as LCS. Third one, matrix chain multiplication. Matrix chain multiplication. Fourth one, longest common subsequence. Third one is matrix chain multiplication. Fourth one, 0/1 knapsack. So fifth one, sum of subsets problem. Sum of subsets problem. Sixth one, all pair shortest path. All pair shortest path. Seventh one, optimal cost binary search tree. Optimal cost binary search tree. Thank you, Robit Kumar. Thank you so much. So these are the syllabus, right? Please write everything. Please write everything. My request to everyone, please write everything. Please write everything. You have to make your own notes. You have to make your own notes. My sincere request to everyone, make your own notes. Don't ask, sir, can you give the notes and all? Don't ask. Don't ask, sir, can you give the notes and all? Don't ask. And today's date I am writing. I am writing the today's date also. I think today's date, if you see, I think 06/11/2024. This is the date. Right? Syllabus is started. Write the nice notes. Notes is nice. Right? You will get more interest of reading. Notes is nice. You will get the more interest of reading. You will get the more interest. It is the first chapter. Analyzing algorithm. It is a common topic for the algorithm subject. Everywhere the story will come. Time complexity finding, space complexity finding, everywhere it will come. You have to make nice notes. This will be useful forever in your life. You joined job also, it will helpful. You went to the higher studies, then also helpful. Everywhere it is useful. Everywhere. I will cover A to Z. I will cover A to Z. I will cover A to Z. In the divide and conquer, these are the topics. In the divide and conquer, these are the topics. Finding maximum, minimum, power of an element, binary search, merge sort, quick sort, counting number of inversions, maximum continuous subarray sum, selection procedure, Strachan's matrix multiplication, greedy technique. In the greedy technique, knapsack problem, job sequencing with deadline, Huffman coding, optimal merge pattern, minimum cost spanning tree, single source shortest path. Next one, dynamic programming. Fibonacci series, longest common subsequence, matrix chain multiplication, 0/1 knapsack, sum of subsets problem, all pairs shortest path, optimal cost binary search tree. So let's have clarity. Anything you have doubt, let me know. Anything you have doubt, totally almost like 7 topics. If you okay, I can move to the next story. Just to follow whatever I am saying, just to follow. If you okay, please type in the comment section okay, so that I can proceed to the next story. If you okay, please type in the comment section okay. Then I can proceed to the next story. Everywhere, this is the fundamental one. In the computer science, if you want to survive, This subject is major. You want to do something. You want to do something in the computer science. This subject compulsory. Algorithm followed by data structure compulsory. It is a compulsory. It is a compulsory. Please learn properly. Don't by heart. If you are more good, you will get the better job. If you are okay. If you are okay, then you will get okay job. If you are little bit, then you will get a small job. You know algorithm and data structure little bit. You will get a very little bit job. Small job you will get. If you are average in that, right, data structures and algorithm, you are average in the DSA, you will get the average job. You are extraordinary in the DSA, you will get the extraordinary job, maybe 5 lakh per month job. Please remember how much strong you are in this subject, right? That kind of job you are going to get. How much strong you are in this subject, that kind of job you are going to get. You may say that, sir, I don't know algorithm. I also don't know. I also studied. I also learn. Every day I learn little bit. Sir, I am completely zero, sir, in algorithm. I also zero. Few years back, I also zero in algorithm. I also studied. My students also studied. There are some students who don't know anything about algorithm. But finally they became so good. Yashwant is asking something. Yeah, Yashwant. Yashwant, yes. Check properly. Everything, please study everything, whatever I am saying. Everything, whatever I am saying, please study one time. It's a more than enough. It's a more than enough. One time study. Right. And one more thing, my sincere request to everyone. One more thing. If you little bit sleepy also, assume that you are watching this lecture, you are little bit sleepy. If you are little bit sleepy, you slap yourself like this. Everything okay. Are you sleepy? You slap yourself like this. Do 5 times like this, everything is all right. If you are sleepy, just slap yourself. If anyone is little bit sleepy also, I'm going to start this subject now. If you are little bit sleepy also, please slap yourself. Take one glass of water, throw on your face. Otherwise, go to your bhaiya, slap your bhaiya. He will slap you double. You slap your bhaiya like this. Your bhaiya will slap you double. Then automatically your sleep will go. Beat your behan. Beat your sister. She will beat you once again. Then everything is okay. My sincere request is, if you little bit sleepy also, please can you control? Little bit sleepy also, can you control? Yeah. Now come to the next story. I think everything is fine. Write the definition for algorithm. Algorithm definition, right? I'm starting now. Algorithm definition, I'm writing. Definition. Algorithm definition. It is a combination of sequence of finite steps. It is a combination of sequence of finite steps to solve a problem. It is a definition. See, I started with the definition. Everyone will get. I never seen a person who don't, right? I never seen a person, he attended my lecture of algorithms and he didn't get algorithm. I never seen a person. If you don't know algorithm, you will also get. Every student of mine got algorithm subject. You will also get. Definition onwards I started with the definition. It is a combination of sequence of finite steps to solve a problem. It is a combination of sequence of finite steps to solve a problem. That is the definition. Now some people are asking, sir, what it means? Can you give an example? Let's take one example. Sir, can you give one example? Yeah, I'm giving. You can write any program, whatever programming language you want, you can write. Just I'm writing pseudo code kind of thing. I'm writing pseudo code kind of thing. See this one. Addition of two numbers. Addition of two numbers. I want to add two numbers. Addition of two numbers. I want to add. See the algorithm. Addition of two numbers. I want to write algorithm. I'm writing first step. First step. Take two numbers. Take two numbers. Assume they are. Assume they are A comma B. Right? If you want to add two numbers, see, adding two numbers, I am writing algorithm. Adding two numbers, I am writing algorithm. See, addition of two numbers, I am writing algorithm. First step, take two numbers. Assume they are A comma B. Take two numbers, right? Okay, I done. Next one, can you see this one? 2. Add both A and B. Add both A and B. Store in C. Add both A and B. Store in C. That is the second step. You want to add two numbers. First step is take two numbers which you want to add and add both of them, both A and B, store in C. Third step. If you want to print that C, you can print. If you want to return that C, you can return. Print C. Print C value. Print C value. So end of the algorithm. This is the algorithm. Addition of two numbers. Yeah, of course. Abhinav, everyone will get. I seen many people. They don't know anything. Still they will get. I will take care. It doesn't matter what is your background. If you are determined, you will get. If you determined, you will get. If you determined, you will get. It doesn't matter what is your background. You are studying BTech means, right? You will get it. Are you studying BTech? Or are you studying bachelor's degree? Easily you will get it. Right? So some people are asking, sir, what is the algorithm definition? See, I written the definition. Now, sir, can you give one example? I give an answer. Now I will explain. Why it is an algorithm, I will explain. It is a definition. So remember, algorithm subject started here. I am writing the boundary also. Actual algorithm subject started here. If anyone came late, don't worry. From here you can follow. Algorithm subject started from here. Right? So algorithm, it is a combination of sequence of finite steps to solve a problem. So definition I written. Some people are asking, sir, can you give one example? I written the example also. Sir, I didn't get the example. You will get. I will explain. Don't worry. You will get. Don't worry at all. And one important thing, if you have any doubt, post in the comment section. If you have any doubt, post in the comment section. I'm there here to help you. Little doubt also there. Post in the comment section. It is a combination of sequence of finite steps to solve a problem. Right? So I written the program also. Now understand. Everyone try to understand. This algorithm contain how many steps? Remember, every line is one step. Every line is one step. So see this one. If I want to say in another way, some work is there. Little bit work there. Make it as one statement. So this is the first step. Some work. It is also some work. Every work is nothing but one step. So in this algorithm, if you observe clearly, finite steps are there. So remember, algorithm means finite steps. Whenever you say it is an algorithm, finite steps should be there. This algorithm contains 3 steps. 3 is a finite number. So every time remember, algorithm means finite steps should be there. That may be 3 steps. That may be 30 steps. That may be 300 steps. That may be 3 lakh steps. Algorithm means finite number of steps needed. Every work is nothing but one step. If you think that some work is there, oh, some task. Work is nothing but some task. Oh, is it some task? Taking 2 numbers is a task. Yes. Some work is there. So one step. Adding both of them, storing in C. It is also one task. Yes. So that is also one step. That is also one step. Next one, printing a number. Is it also some work? Yes. Without printing, how can you see the result? So that is also one task, which is nothing but one step. So remember, algorithm means finite steps needed. If anyone asks you from today onwards, I given something to you, is it an algorithm or not? First condition you have to verify. First condition you have to verify. Finite steps are there or not there, check. Is it algorithm? First step. Finite steps are there? Yes. Finite steps are there? Yes. Yeah, it is algorithm. Every algorithm should have finite steps. Okay, finite steps are there? That is also okay. Next one. It is a combination of sequence of finite steps. Remember? See, remember everyone. Remember everyone. If you think second one is not required, then why you written? If you think that first one is not required, then why you written? If you think that third one is not required, then why you written? So remember, algorithm means combination of all these three required. If I feel something is not required, I don't write. It is a combination of all three compulsory. It is a combination of, and one more. What about sequence? So after 1, 2 will come. Without taking two number, how can we add them? Next one. Without getting the result, how can you print them? Right? Order. Order also important. When you say it is algorithm, right? Finite steps should be there. When you say it is algorithm, combination of. If you think that second one is not required, then why you written? It's a combination of sequence of. See, sequence. First one will execute. After 1, 2 will execute. After 2, 3 will execute. Right? Mostly order is there. Without taking number, how can I add? Without getting the result, how can I print? So this is the order. From today onwards, if anyone say what is the algorithm definition, simply say it is a combination of sequence of finite number of steps to solve a problem. Finally, it should solve your problem. Finally, it should solve your problem. Suppose problem is not solving, there is no point of writing algorithm. Suppose someone will say that I written algorithm, it is not solving anything, then why you written? Algorithm should solve the problem. What is our problem here? Printing, right? Adding two numbers. What is your problem? Adding two numbers. Is it doing adding two numbers? Yes. Finally, it should solve the problem. Algorithm is finite number of algorithm, nothing but finite number of steps. And algorithm is nothing but all statements are necessary. Algorithm is nothing but sequence of steps. So this is the definition. Someone asks you algorithm definition, say this definition, followed by give this example and explain them. Explain them why it is algorithm. Finite steps and all steps are necessary. And one more, after first step, second step will come. After second step, third step will come. See, I cannot swap 2, 3. I cannot swap 2, 3. I cannot swap 1, 2. Right? Sequence also. Most probably sequence also important. Most probably sequence also important. If anyone having any doubt till now, let me know. If anyone having any doubt, let me know. I said first syllabus, then I went for algorithm definition. I give an example also. Yeah, if anyone having any doubt till now, let me know. What is algorithm? What is algorithm definition? It is a combination of sequence of finite steps. There are so many definitions. There are so many definitions for algorithm, right? Every book having some definition. Indirectly, directly, all are doing the same work. If you take some other book, some other definition. If you take some other book, some other definition, like that, there are so many definitions, book to book. One definition, please get, that is more than enough. Now, some people are asking, sir, definition okay. Definition okay. Next one, what are the properties of algorithm? Let me write. Write down properties of algorithm. What is the meaning? I will explain. Just write properties of algorithm. Algorithm definition okay, but what are the properties of algorithm? What it means, I will explain. What is the exact meaning of properties of algorithm? I am going to explain. Yeah. Anyone having any doubt till now? If you don't have any doubt, can you keep in the comment section? Right? Right? Can we right? Go to the next one, sir. If you okay, please type okay, so that I can go to here. If you comfortable until now, please say okay. Everyone, if you are okay till now, please say okay. No doubt there, sir. Yes, sir. Give some signal. Everyone, please type. Everyone, please type. If you don't have doubt, say don't have doubt. Give some signal so that I can proceed further. Yeah. Everyone, whoever watching, everyone, please respond. Everyone should respond. If you don't have doubt, say don't have doubt. If you don't have doubt, say don't have doubt. And one more my request to everyone. Everyone is watching the video and they are going. If you watch and if you go, who will like, yeah? Please like, man. Please like and subscribe. Everyone watching and going. Then who will subscribe, yeah? Watching and going, who will subscribe? Then please click on the subscribe button. Please click on the like and subscribe so that some more people will see. They will also get the advantage. Can you like and comment and subscribe? Everyone, whoever watching, please do that. Before going to the next one, can you comment and can you subscribe, and if possible in your friend circle also you can share. Now come to next one. Properties of algorithm. What are the properties of algorithm? Can you see this? Can you see this one? Based on the above definition, one of my friend is right. See this one. Based on the above definition, one of my friend written something. Based on the above definition, one of my friend is written something, and he came to me and is asking, right? And he came to me and is asking, whatever definition you given for algorithm, right? Based on that definition, I written the something. Is it algorithm or not? How you verify? Is it algorithm? How you verify? One of my friend came to me and is asking, I written something. Is it algorithm or not? How you verify? Right? So then you have to check these conditions. See the first condition. Properties of algorithm. If anything is an algorithm, it should satisfy some properties. What is the first property? I am going to explain. Listen. Everyone listen. Is it algorithm or not? Is it algorithm or not? What is the first property I am going to check? See this one. If it is an algorithm, right? This algorithm should stop after finite time. So let's write the first point. It should stop. It should stop after finite time. Whenever someone said it is an algorithm, it should stop after finite time. Be careful. Some people are asking, sir, I written something, it is not stopping. Is it algorithm? No. Algorithm means it should stop after finite time. Finite time may be 10 minutes. Finite time may be 20 minutes. Finite time may be 1 lakh minutes. If it is an algorithm, it should terminate after finite time. And one more. Second point, stopping okay. Sir, if it is algorithm, after finite time it should stop okay. But after stopping, no output is there. Then what is the use? Remember, if it is algorithm, it should produce. If it is algorithm, it should produce at least one output. At least one output. If it is an algorithm, right, it should produce at least one output. Some people are asking, sir, what is the use of properties, sir? Someone is asking me, right, I have something, please can you verify it an algorithm or not? As soon as you take that particular one, immediately check, is it stopping or not? Is it terminating or not? If not terminating, it is not an algorithm. Next one, terminating, but no output. If terminating, no output. If no output is there, what is the purpose of writing algorithm? It should produce at least one output. It should produce at least one output. It can print two outputs also. It can print 10 outputs also. It can print 25 outputs also. At least one output is required. Whenever it is an algorithm, at least one output required. If at all you are a human being, if at all you are a human being, you should be useful to something. You want to say this only. One student came to me and asking, Reddy sir, can you verify, am I a human being or not? Reddy sir, can you verify, am I a human being or not? Immediately I will ask only one question. Are you doing at least one useful work? At least one useful work. If it is an algorithm, at least one output will produce. If at all you are a human being, at least one useful thing you should do. Next one, eating, sleeping, eating, sleeping, eating, sleeping. Then you are not a human. When people will say you are human means, at least some useful work required. Mama feel that my son is doing some good work. Papa should feel that my son is doing good work. Bhaiya should feel that my brother is doing good work. Sister is saying that my bhaiya is doing extraordinary work. When someone will say that you are doing some good work which is useful to society, which is useful to at least family, which is useful to at least yourself, at least yourself you are useful, then you are a human being. At least you are useful to yourself, or at least yourself or family, or maybe society, then you are a human. In the similar way, algorithm also. Is it algorithm? Then at least one output required. Next one. Sir, output is coming, but it is not stopping. If it is not stopping, how I know it is coming output or not? If it is algorithm, right, it should stop after finite time. If it is an algorithm, at least one output it should produce. Third step. And one more thing, if it is an algorithm, it should be deterministic. If it is algorithm, it should be deterministic. What is the meaning of deterministic is? There is a one algorithm. See this one. This is the algorithm. Everyone listen. This is the algorithm. To this algorithm, I give an input and x and y. If I give x and y as input, I got z as output. After some time, again, if I give x and y, I should get output z only. Suppose, right, first time if I give x, y, I got z. Whenever I will do second time x, y, I got something like w. Then it is not deterministic. When you say deterministic means, right, if I give x, y, I got z output. If I give the same x, y, after some point of time, if I give same x, y, you should get z only. You cannot get something else. Same input, right, you are expected to be same kind of output. Inputs are same, outputs are different, then it is a serious issue. Then I cannot say it is not a deterministic algorithm. Remember, it should be deterministic. Algorithm should be deterministic. Algorithm should be deterministic. Yeah, when can I say it is an algorithm? First step, it should stop after finite time. Second step, it should produce at least one output. Third step, it should be deterministic. It should be deterministic. Some people are asking me, at least one output should come, that's okay. What about input? Input you may give, you may not give. Input you may give, you may not give. But at least one output required. Sir, how many inputs you have to take? 0 or more. Inputs, how many you take, I don't care. But at least one output required. Yeah, if anyone thinking that something else is there, please let me know. Three properties I written. If you think that some other property also, right, please let me know, I will write. When can I say it is algorithm? It should stop. It should stop after finite time, and it should produce at least one output. It should be deterministic in the nature. If you think that something else is there, let me know. If you think that something else is there, please let me know. 3 points I already written. If you think that something else is there, please let me know. Properties of algorithm. It should stop after finite time. It should produce at least one output. It should be deterministic. If anyone think that something else is there, sorry, if at all it is algorithm, this property should also be hold good. Let me know, I will write. Anyone? All steps should be relevant. Yeah, I will write that also. I will write that also. Thank you so much for saying. I will write that also. In algorithm, between each statement, in algorithm between all statements, there should be some relation. There should be some relation. In algorithm between all statements, there should be some relation. If you want, you can go over and you can check where C came from the second step. Where, right? What is the purpose of right, second step? AB required. Why AB required? So first one saying take AB. So in the algorithm between every two people, there should be some relation. Yeah, someone is saying it should be effective. Thank you so much. I will write that also. It should be effective. Some people are asking, sir, what is the meaning of effective? I will write that. It should be effective means, listen, it should be effective means you cannot write in the algorithm A is equal to A. Why are you writing A is equal to A? A is equal to A only. Why are you writing? Right? There is no meaning of writing A is equal to A. These kind of statements you can avoid. No need to write this. B is equal to B. No need to write this. It's a wastage of time. It should be effective. In algorithm between all statements, there should be some relation. It should be deterministic. It should produce at least one output, right? And it should stop after finite time. Hi, Don. Hi. Thank you. Anyone feel something else is missing? Let me know. Anyone feel that something is missing? Let me know. If it is suitable, I will write. If not suitable, I will say no. It should be effective. I written already. Swati, if anything else, let me know. Everyone respond. Anything else you feel? It should stop after finite time. It should produce at least one output. It should be deterministic. In algorithm between all statements, there should be some relation. Right? From the first one, second one. First and second, there is some relation. Second and third, there is a relation. In algorithm between each two statements. Between every two statements. You can write like this. In algorithm between every two statements, there should be some relation. Right? So if you take 1 and 2, there is a relation. Just 1 minute. Yeah, let me know if anyone having any doubt. All these things, please take care. I can write so many properties are there. I can write all of them, but no use. Some people are asking, sir, what is the meaning of effective? You cannot waste time and space by writing A is equal to A. If you don't write A is equal to A also, same only. If you write B is equal to B also, same only. What is the purpose of writing? So that is the meaning of it should be effective. In algorithm between every two statements, you take any two people, there is some relation. Next one, it should be deterministic. What is the meaning of deterministic? If I give sometimes XY input, I got the Z as the output. If I give the XY after some time, I should get Z only. I cannot get something else. And whenever it is algorithm, it should produce at least one output. If no output is there, there is no point of writing. Sir, output is coming, but it is not stopping, sir. Then it is not an algorithm. If it is algorithm, it should stop after finite time. Yeah, if you agree till now, if anyone say, ready, sir, until now we are fine, sir. You please let me know, give the conclusion, then I can move to the next story. Please confirm. Please confirm. If you are confirmed, then I can move to the next one. Everyone, please respond. If you are okay, if you are okay, if you are okay, then I will move to the next one. So every time I need your signal, because I'm teaching for you only. If you don't respond, who will respond? Okay, you are not responding, then whom I have to ask? You are the one who is listening my lecture. If you don't respond, who will respond? Yeah, can I move? Yes. If you okay, now come to the next story. See, there may be, you may say that, sir, in one book, in one of the book, 20 properties are there. Yeah, there, I can write infinite things also, but there is no use. It is a wastage of time only. These are more than enough. These are more than enough. Then write the next one. Then write the next one. Write the next one. Steps to design algorithm. Steps to design algorithm. What it means, I will explain. Take it. Steps to design algorithm. Steps to design algorithm. Right. Just give me 1 minute. I didn't ask my madam. I didn't ask my madam. She took the tea. Right? I didn't ask my madam, but she took the tea. If I don't take that tea, right? So maybe she came with a lot of love. She made with a lot of love, right? So if I don't take that tea, she may feel bad. Just give to me 2 or 3 minutes. I will finish it off. She came with a lot of love. She made the tea, right? If I don't take, maybe I don't think good. But I didn't ask her. But she came with the tea. What can I do? Just give to me 2 or 3 minutes. 2 or 3 minutes you give, right? I will proceed further. Yeah, done. Done. Thanks for your patience. Thank you so much. Next one. Steps to design algorithm. Some people are asking, listen, some people are asking till now, right? Ready, sir, whatever you said till now, we are happy, right? What is the meaning of steps to design algorithm? What is the meaning is, I have a problem. I want to design an algorithm. How can I proceed? Is there any procedure? I have a problem. To that problem, you have to design the algorithm. Is there any procedure? Or I have to do manually? Remember, right? So remember everyone. So if you do right, if you do hit and try, every time hit and try method may not work. There is some procedure. For any problem, if you want to solve, means for any problem, if you want algorithm, there is some standard procedure. There is some standard procedure. Please follow that. Sir, can I do hit and try? Hit and try may work, may not work. The best way as a professional, the best way to solve any problem is please follow these steps. Every software company follows these steps. Every software company follow these steps. I have a problem, I want to design algorithm. Every software company follows these steps. Some people are asking, sir, what are those steps? Can you see the first step? Every software company follows normally these steps. See the first step. I have a problem. I want to design algorithm. Right? What are the steps I have to follow? First step is knowing the problem clearly, which is called problem definition. Know the problem clearly, which is known as problem definition. You want to design algorithm for any problem? Yes. Then know the problem clearly. That is called problem definition. Every software company, you go to any software company, you want to design algorithm for any problem. The first step is knowing the problem clearly. Right? If you don't know the problem clearly, if you want to design algorithm, it is impossible. You will stop somewhere. Don't do hit and try method. So you want to solve the problem, hit and try. Directly starting algorithm and all, it don't work. The first step is know the problem clearly. So when you say problem definition is over means, remember problem definition is over means they got clearly what is the problem. They will make one document also, SRS document, software requirement specification document. They will make one document, which is also called proposal. Right? Different companies will call different names. Some companies will say SRS document. Some company will say proposal. Right? Some right? Different companies will say different names. So knowing problem clearly is known as problem definition. Depending upon what you understood, you make one document that is called SRS document, software requirement specification document. See how that document look like. Listen, how that document look like. Wherever problem definition is going on, right? Company people and a client. One client came and he is saying that I want algorithm to my problem. So these company people are talking with that client. They both will talk each other. Company people are asking the client, to your problem, if I give A as input, what is the output you are expecting? So he said B. Okay, to your problem, if I give C input, what is the output you are expecting? D. Okay, to your problem, if I give E as input, what is the output you are expecting? F. Like that, they both will discuss. Right? Company people and the client, they both will discuss. So understanding problem clearly. Suppose assume, if I give X as input, what is the output? Right? Company people are asked the client to, right? To your problem, if I give X as input, what is the output you are expecting? If client will say, I don't know, means he is not clear with the problem. If he is not clear with the problem, how can I give the algorithm for that? If I want to give algorithm, for everything, you should know what exactly happening. So I have to ask the client, let us assume that to your problem, I am giving X as input. Please let me know what the output. We are having a dilemma. For X input, what the output you are expecting? We are thinking that output is Y1. Output is Y1. We are thinking. Client will say, I don't think Y1. Maybe Y is the output. So after discussing with each other, so I think output is Y. Right? Next one, W input. Maybe Z output. Like that, they will make one document. So when both the people are agree, company people and the client, both people agree, they will make one document. They will simply say that based on your input, we made this document. So according to your opinion, A input B output, C input D output, and so on. W input Z is the output. So client will say, yes, I agree. If both agree, both the people will do sign also. In this on this document, both the people will do. Company people also will do sign. Client also will do. Customer or client also will do. They both will do sign. They will make one document. At the end of the document, they will make the signs also. I agree. Right? Client also will say, I agree. Right? Company people also will say, I will agree. Employee or company people, whatever it is. Employee or developer. So they both. So if you are comfortable, can I move to the next one? So if you want to design a algorithm for any problem, this is the first step. Know the problem clearly. You want to design algorithm for any problem. First step is know the problem clearly. Problem not clear, please don't go next step. Problem not clear, please ask the customer. Please ask the client. Hello client, for your problem, we have some problem. Can we have coffee and can we discuss? Hello client, for your problem, we are troubling somewhere. Tomorrow, if you are free, can you come to office? Can we have a call? Can we discuss? So like that, they are keep on calling, keep on discussing. If at all it is a complex problem, maybe discussion may goes to 6 months. If at all more complex problem, discussion may goes to 1 year. If it is an easy problem, discussion may be 1 week. Very easy, discussion may be 1 day. So knowing each and everything of the problem is known as a problem definition. Okay, if the problem is clear, they will make a document also. It may be SRS, company to company, there is some change. Software requirement specification document, SRSD. There are different names are there, it is not standard name because every company cannot follow similar way. Different companies follow different way. In the startup companies, there are less people are there. So they, small names. They don't make complex. In the big companies, because of more employees, right, and the project cost also more, they will keep the so many names for that. So different companies are in different model. Let us assume that they made one document, whatever problem they understood, they made one nice document, both the employee, client, both are on the side, then problem is clear. If problem is clear, we can go to next step. See the second step. See the second step. Everyone try to understand. See the second step. Concentrate everyone. Knowing problem clearly is known as a problem definition. So problem is clear. Problem is clear. Now see everyone. Everyone see. Second step is very crucial. Second step is very crucial step. After knowing the problem clearly, then this document will be sent to the developers. Listen, this document will be sent to the algorithm designers. Whenever you make the document, that document will go to the algorithm designers. Means there are some experts are there in algorithm subject. There are some experts, some seniors are there. Some seniors are there in that domain. So this problem will be sent to them. They are the algorithm designers. What they will do is, listen, they will see the problem. They will see the total document. They will read the total document one time. Because of they have a lot of experience, they are so good in algorithm subject, they will simply say that, everyone listen, they will simply say like this. After reading the document, what the algorithm designers, senior algorithm designers, what they will do is, after reading this problem, I got to know that this problem can be solved using greedy technique easily. Greedy is a one model. So that algorithm designer got to know that, oh, this problem can be solved very easily using greedy technique. Right? After reading the document, they got to know that, oh, this problem can be solved easily using divide and conquer technique. Oh, this problem can be solved using dynamic programming. So what I mean to say is, remember, for every problem you no need to do brute force. For every problem you no need to do brute force. Some people are thinking, every problem can I do brute force? No, bhaiya. The algorithm subject having already some techniques. Just identify your problem belongs to which technique. By seeing the problem, see, experienced algorithm designers, what they will do is, by seeing problem, they will say, oh, this problem, greedy better. Oh, this problem, dynamic programming better. Oh, this problem, divide and conquer better. So remember, algorithm writing is nothing but no need to write from scratch every time. Just identify this is belongs to which model. Your problem belongs to which model, right? So that's what I'm saying, which is nothing but algorithm is nothing but template. So to solve your problem, which template is better? Can I solve this problem using divide and conquer template? Remember, every designing technique is nothing but one template. Suppose e-commerce website, if I want to design e-commerce website, if I want to design e-commerce template, I will take. You no need to write from scratch total code. Suppose real estate company website, if I want to make real estate company template, I will take. Every domain having some template. So using that template, I will solve it. So remember, algorithm subject having so many templates. One template name is a divide and conquer. One more template is greedy technique. One more template is a dynamic programming. One more template is backtracking. One more template is a right branch and bound. There are so many, right? There are so many templates are there. In your syllabus, only these 3 templates are there, which are nothing but designing technique. Remember everyone. After seeing this particular document, senior algorithm designers got to know that this can be solved easily using divide and conquer template. This can be solved using greedy template. This can be solved using dynamic programming template. So those are called as algorithm experts. So second step is going to be, right, design a algorithm. This is the crucial step. I am changing the color also. This is the major one. Design algorithm. After reading the document, they got to know, oh, this problem can be solved using the template of greedy, right? Because of their experienced people, because of their experts in the algorithm, they know which technique they have to use. Suppose if you are not an experienced one, you are a fresher, everything you write from scratch. So second step is going to be, after seeing the problem, after reading the SRS document, so they got to know that, right, greedy is better. So design algorithm. That is the second step. First step is know the problem clearly. After knowing the problem clearly, explain that problem clearly. Algorithm experts, algorithm design experts, please explain. Because of they done so many, they have so many templates. Oh, this is the real estate. This is the real estate website. You want real estate website? Go for real estate website template. Because we have already real estate website template is there. Use it. Problem will be solved easily. Oh, I think, oh, this business is something like education. Oh, education template required. So I will ask the developer, education template we have? Yes. So this problem can be solved using education template. So remember, algorithm design is nothing but which template you have to select, right? That is nothing but algorithm design. I have already templates. Remember, algorithm designing is nothing but we are not creating the new algorithm. We are just mapping. Your problem belongs to which template? Greedy template or divide and conquer template or dynamic programming? Just you have to verify your problem belongs to which template. Right? Suppose if I give to one of the algorithm designer, he will say your problem is mapped to greedy. So that story is called design algorithm. Design algorithm is not designing from the scratch. Designing algorithm is nothing but mapping your problem to one of the existing template. Mapping your problem to one of the existing template. So try to understand. So second step is over means you got template also. First step is over, problem clear. Second step is over, to my problem, which template is suitable? I already selected. Can anyone help me? Till now, template selection done or not? Till now, template selection done or not? Algorithm design is nothing but not designing from the scratch. Algorithm design is nothing but just mapping to your problem which template I have to map. I have my problem in front of me, so many templates are there. To my problem, which template is suitable, I have to map. That mapping is nothing but algorithm design or design algorithm. If you okay second step, I can go to third step. So second step is over means, listen, second step is over means my problem is mapped to greedy. Your problem is mapped to available techniques. So many techniques are there. For one of them, I mapped it. Divide and conquer. Finally, this is the mapping done. If you are comfortable, please can you comment in the comment section. Algorithm design is nothing but mapping to your problem. Which template I have to map? Can you comment? Hello? Everyone, can you comment? Designing algorithm is nothing, but I am not designing. I have already so many designs. I have already so many designs. To my problem, which design is suitable, I have to map. To my problem, which design is suitable, I have to map. Sir, how many designs are there? Major designs are greedy, divide and conquer, dynamic programming, and one more thing is right, backtracking. One more thing is branch and bound. There are so many designs in front of me. So many designs. Everyone knows shopping means I am not designing any cloth. So let us assume that to buy cloth, I am going to one of the shop. So I am going for shopping. I don't stitch the clothes. I don't manufacture the clothes. So in front of me, so many clothes are there. Which cloth is right map? Which cloth is suitable to me? I will map it. That is called as shopping. So algorithm design also similar. In front of you, there are so many algorithm designs. There are so many templates are there. Which template is suitable? Select. Let us assume I got to know this is not suitable, this is not suitable, this is not suitable, this is not suitable. So to my problem, greedy is suitable. So this mapping is called designing algorithm. This mapping is called designing algorithm. So remember until now I have only template. I have until now only template. So I went to the shopping. In front of me, so many clothes they kept. I selected one of them. Then, right, you have to do small modification. After selecting something, I have to go for small thing. I think that may be right so long. So they will go as per my size. They will cut something. Suppose that is very small. As per my size, they may increase. Suppose that is very loose. As per my size, they will right. They will cut it, right. But when I wore it, I got to know that it is very tight. They may right. They may increase a little bit. What I mean to say is, till now I have only template. I selected the cloth. Then as per to my requirement, some small adjustments should be done. That is the next story. See the third step. Right. Problem definition clear. Designing means mapping also done. One of the cloth I selected. After selecting one of the cloth, I think according to my requirement, some design should be done. So see the answer. Next one, draw flowchart. Flowchart draw. Because of you have template, already you got some idea. Draw flowchart means almost like checking one by one, right? Because of you have a template, please check clearly the template, whatever you selected, what is the flow? What is the flow? In the form of a diagram, you write. You selected template, okay. In that template, how the flow is there? So draw the flow, right? Flow in the form of a chart, you write. That is called flow chart. After drawing the flow chart to your problem using this template, just apply according to this flow chart, right? This input is given, what the output is coming. So please verify. Suppose assume that somewhere, right, it is not proper inform to algorithm designer. He will do some changes. Flowchart is nothing but almost, right, wearing the dress. You already selected one dress. Afterwards, you go to trial room, you start checking. Suppose assume that it is so tight, right? It's informed to algorithm designer. It is tight. It is tight. They will make little loose, right? Suppose you got to know that somewhere it is so loose. Informed to algorithm designer. They will write one line code extra. They will delete one line, right? They will increase the condition. They will decrease the condition. Like that, it is a keep on going. It is a keep on going. Draw the flowchart. After flowchart is over, right? So at anywhere small misunderstandings are going on, you inform to designer, they will design it. Accordingly, they will design. And let me write that also so that you will get a clarity. Fourth one, after flowchart is over, whatever design you selected, for that you draw the flowchart also. Then by applying these inputs, whatever inputs you have, by applying these inputs, you please keep on check. This is called testing. This is called testing. Design a algorithm, or means a template available. Draw the flowchart for that. Because of you have a flowchart also, you know how to check. Right? Because of you have a flowchart, you know how to check. By using these inputs, please verify. Suppose using that A given, B not coming. Inform to right design person some problem, right? A I given, B I am not getting. You will do some adjustment. Again draw flowchart. Again check. Yeah, then perfect. Next one. He will give C also. But D not coming. He will inform to designer. I think I'm not getting C, D, I'm not getting. You will do some small changes. Once again, flowchart will change, right? Once again, testing. So like that, it is keep on going. E, F should come. X, Y should come. W, Z is coming. So like that, they will keep on check until all are correct. Until all are correct, this testing is keep on going, right? So first to select the template. Next one, to that template, draw the flowchart. Now you have flowchart, you know how to verify. So you, right, that is called verification, is called testing. If you have your flowchart, then you can verify. That verification is called testing. So this story keep on going. Now can anyone help testing successful? What is the meaning? Testing successful means is everything okay? Testing successful means is everything okay? Testing successful means is everything okay? Hello? Testing successful means is everything okay? Everyone respond. Everyone respond. Testing successful means is everything okay? Hello? Hello? Testing okay means is everything fine? Everything fine? When you say testing is over, means everything fine. The only thing is program not there. See, I have a flowchart. I have a flowchart. See, this is a skeleton. Designing is template is nothing but skeleton. Flowchart. Flowchart means a diagram. So in that, right, you are keep on checking. Whenever everything okay, then lastly go to coding. So fifth step. Right, fifth step is going to be right, analyze the logic whatever you done. Careful everyone, the logic whatever you done, right, until now. Whenever you say that testing successful means you have some logic, right? That logic working nice. So whatever logic you have till now, that logic try to analyze, means how much time, how much space, try to find out. How much time, how much space, try to find out. How much time, how much space, try to find out. Suppose if you think this time is okay, this much time is okay, then lastly you can go for coding. Coding is the last part. Then go for coding, which is also called implementation. Last step is coding. Whenever you got to know the logic which you done, everything is fine. Analysis over. You got to know everything is fine. Then lastly go for coding. So that that program will run inside computer. Till now it is not running inside computer. It is outside only because flowchart diagram is there. Until now we have diagram. In the diagram we are checking. Whenever you got to know this logic is perfect, then write coding. Then write the coding inside the computer, it will work. Other than this, nothing. Right. Again, I'm starting now. If anyone say from today onwards, I have a problem, I want to design an algorithm, what are the steps I have to follow? Don't do randomly, follow this procedure. Know the problem clearly. Means for every input, what is the output, please find out. Make one nice document, otherwise you may forget also. So whenever this document is ready, means problem clear. Next one, you have a problem, in front of you so many templates also there. Divide and conquer, one template. Dynamic programming, one template. There are so many templates. So to your problem, which template is more suitable, check. I give an example also. You went for shopping, it is you, in front of you so many clothes are there. Which cloth you like, please select one thing. That is called as algorithm design. That is called shopping. So select one thing. Select one thing. After selecting one thing, what you do is, right, to that one, go to the trail room, please check. If something is wrong, please inform to designer. Again, you will do some changes. Once again, go to trail room. Once again, check. Again, some problem, inform to designer. Again, you will do small changes. Once again, go to trail room. Once again, check. So it will continue until all will match. Okay, all are match. Then that means this logic is working fine. But I don't know that logic is efficient or not. I don't know. Logic is working fine, but is it efficient or not? I don't know. First verify, is it efficient? Find out time complexity, space complexity. If you think that this is taking less time and less space, then keep that particular logic inside computer by writing the program. That is called coding, which is also called implementation. So these are the steps. Totally 6 steps are there. If you follow, everyone listen, if you follow all these 6 steps, if you follow all these 6 steps, that means algorithm is designed for your problem. If you follow all these 6 steps, that means for your problem, algorithm is designed. Some students are thinking that algorithm designing is nothing but, to your problem, algorithm designing is nothing but from scratch I will do. No, bhaiya. No, nothing from scratch. Kids only will do from scratch. All experienced people, what they will do is, they have so many templates. To your problem, which template is suitable, they will check first. So they will take this template. Oh, greedy is suitable, right? Greedy template they will take. To that template, they will do some small adjustments. So I taken the greedy. So I selected one dress. I will go to the right a trial room. I will verify. If something is wrong, I will inform to that, right, that particular trailer, the person who will do the stitching and all. So that person I will inform. He will do some loose or some tight. He will do. Once again, I will go to trial room. Once again, I will check. Continue until everything is fine. If at all everything is fine, then you will analyze, is it okay or not? Everything perfect, then you will go to the payment and all. Lastly, this is called almost like payment. This is before that. After all changes are over, still it is not looking nice. Analyze, right? If everything is fine, then only go to payment. If not fine, inform, it's not up to the mark. So something like that. Yeah, is flowchart same as we do in the programming? Of course, that flowchart only. Normal flowchart, right? See, flowchart contain diagrams. Coding contain coding. Flowchart contain diagram. Same program representing in the form of a diagram. That is called flowchart. The only thing is you are not writing code. Diagrammatic representation you are doing. program diagrammatic representation is called as flowchart. Before going to the coding, do flowchart first. You taken one template. To the template which you selected, template means logic. Template means logic. Whatever logic you selected, to that logic, draw flowchart. Diagram format you write. Right? So after completion of that diagram, in that diagram verify. For every input, correct output is coming in that diagram or not, verify. If not, inform to algorithm designer, whatever template you are taken, everything working, few mistakes are there, they will rectify. Again, flowchart will be adjusted. Again, testing will be done. If everything is ready, then I will go for analysis. How much time it is taking finally? How much cost it is taking finally? Suppose if I feel that everything perfect, then I will go for coding. Coding means finally I can store inside a computer. Whenever I want, I can run it. Yeah, let me know if anyone having doubt. If you follow this procedure, for any problem, you can design algorithm. Normally, freshers, listen, freshers will do every algorithm. Freshers will solve every problem by hit and trial only. Freshers will design every problem algorithm by hit and trial only. Experienced people will use templates. In the existing templates, which template more suitable to your problem? Oh, fifth template suitable my problem. I will take the fifth template. I will do small adjustments. After small adjustment, everything is over. Then I analyze how much time, how much space. If you think that everything is okay, then go for coding. Then it's perfect. Yeah. If you are comfortable, I can move to the next one. So in today's class, we done this. Right? So I started from here. Syllabus I explained, followed by algorithm started. Definition onwards I started. Right? Fine. So I given definition followed by algorithm properties. See, remember, if you write the algorithm by hit and try, you have to verify all these conditions. I written the algorithm by hit and try. I have to verify all. Suppose if you follow this procedure, you no need to check the properties, because you followed some procedure. Automatically, your answer is right. Steps to design algorithm. If you design algorithm by following these steps, automatically properties will be satisfied. If you write the algorithm right by randomly, by hit and try, you have to verify properties. Right? Fine. Tomorrow we'll see some more details. Yeah, it's very good question. Sorting and searching is a part of algorithm, of course. They are also part of algorithm. They will come in further classes. Sunny, please remember, very interesting question. Sunny, please remember, very interesting question. See, testing will be done in many areas. On code also you can do testing. On logic also you can do testing. On design also you can do testing. Many places you can do testing. See, people will make the designs. On the design also testing will be done. They will say this button will be kept here. This button will be kept here. This box will be here. So on the design also testing will be there. On code also testing will be there. There are so many testings. Testing is not a right generalized statement. It can be anywhere. Yeah, analyzing also testing only. Right? Is it good or not? The time complexity, space complexity, how much it is taking, is it good or not? That is also some kind of testing. Normally, testing means you may think that on code only testing. Testing can be done anywhere. Right? As a human, exam writing is a test to us. On coding also testing there is. So testing will be there in many places. After coding is over, then also you can do testing. That is the testing on coding. This is the testing on logic. Sunny, this is the testing on logic. This is the testing after coding. After coding, you can do one more testing. That is the testing on coding. This is the testing on design. Whatever logic you have, to that logic testing is going on. Thank you so much for asking nice question. For asking a nice question, thank you so much. And one more my suggestion to everyone. If you are a GATE 2026 aspirant, 2026 GATE aspirant, 2027 GATE aspirant, one new batch is starting. You can happily join. New batch is starting. This is the new batch starting. New batch starting. You can happily join. Go to exampreptool.com. From there you can join. GATE CSE, GATE DA. New batch starting. You can join happily so that you can complete syllabus. You can complete the syllabus within 6 months. Within 6 months, you can complete the syllabus. Right? New batch starting today only. Happily, you can join in this new batch. Right? Go to the exampreptool.com. CSE means CSE you can join. DA means DA you can join. Within 6 to 8 months, syllabus will be over. Within 6 to 8 months, syllabus will be over. Next one. If you are preparing for placement, DSA course for placements, you can join this course. You can join this course within 3 months. Within 3 months, you can complete. You will be perfect for placements. DSA course for placements. You can join from exam prep tool. Within 3 months, you will be okay for the placements. DSA course for placements. Right? Within 3 months, you can go to exampreptool.com. From there, you can join. So use the code EPT 595 capital ARJ. Use this code, you will get the maximum discount. Use this code, you will get the maximum discount. Yeah. Thank you so much. We will see in the next class. Sir, how much time it will take? Do you think it will be finished? It will be finished within 1 month. Right? Abhinav, it will complete within 1 month. Algorithm will be completed within 1 month or within 20 days. Tomorrow also same time, 5:45. Tomorrow also same time, 5:45. Right. See you in the next class. See you in the next class. Please revise. While coming, revise the class notes and come. While coming, revise the class notes and come. Don't come by dancing. Revise the class notes and come. Tomorrow 5:45 to, actually 5:45 to 6:45, but we are taken until 7:45. 2 hours we are taken. Right? Fine. Thanks everyone. Thank you so much. Those people who are watching this lecture, if you are watching this lecture, please like the class, comment the class, and share also, and subscribe also. If more people like, so it will go to more notifications. Many people will watch the lecture. They will also get benefit. Right? Fine. Thanks everyone. Yeah, you can do whatever you want. Thanks everyone.